We are now going to work our way through the Introduction to Functions handout that is posted as a PDF in Canvas. There's probably no single word that's more important in our course than the word function. Understanding what a mathematical function is a big part of what Math 90 is all about. So let's get started on the handout. In mathematics, a relation is a correspondence from one set of objects to another. Here are three examples of relations. Number one, ID number of students in class, ID numbers. So I listed a few names of students. Each student has an ID number. Email address of students in class is number two. Same students correspond to email addresses. Notice that some students have more than one email address. And the third example is postal zip code of primary residence for students in class. So some of the students have a 94112 zip code and 94116 and another. So that's another example of a relation in mathematics. Now we're going to talk about a special kind of relation, and what's in the box is very important. A function is a special kind of relation in which each element of the first set, called the domain, corresponds to exactly one element of the second set, called the range. So in each one of these examples, the first set is the domain, the second set is the range. Sometimes the domain values are called inputs and the range values are called outputs. So the names of the students are inputs. In example 1, the ID numbers are outputs. In example 2, email addresses are outputs. In example 3, the zip codes are outputs. But now the most important fact about a function is this part of the statement where we say that each element of the first set corresponds to exactly one element of the second set. So not all of these relations, three relations, are functions. In order for this condition to be satisfied, there can be only one arrow starting at each input element. So the ID number of students, each student has just one arrow starting from their name, so it is a function. But in the second example, email addresses of students, there are several students that have two arrows starting from their name, like Gina. So since there are two arrows starting from Gina's name, this email address relation is not a function. The first ID number of students we just said was a function. And postal zip code of primary residence, notice that there's never more than one arrow starting with any name, so that is a function. With a function, it's okay if several arrows end up at the same range output value. So moving down the handout here, I think we've just talked about the information here at these last couple paragraphs. So just another picture to look at. For a function, the domain is the first box, range is the second. The domain contains inputs, the range contains outputs. So let's move on to page 2. In this class, we're only going to discuss functions whose domains and ranges are sets of numbers. So we're ready for exercise 1. Which of the following relations are functions? These are all relations. They all have a domain and a range. They all have inputs and outputs. but only some of them, not all of them, satisfy the function condition. In A, I notice that when I look up and down the list of inputs, there's only one arrow starting from each number. So A, yes, is a function. B, there's only one arrow starting from each input. So yes, B is a function. C, when I look down the list of inputs, number 2 has 2 arrows starting at number 2. 2 corresponds to 4, 2 corresponds to 3. That's not a function because there are 2 arrows emanating from the input value of 2. D, each input value has just one arrow. Now notice all the arrows end up at the same output value. That's fine as long as each input has just one arrow starting at that input value. So D is a function. And then example E, we have 2 arrows starting at -3, 2 arrows starting at 3. E is not a function. Does not satisfy that condition where each input value corresponds to exactly one output value. Now, one example of a function is the squaring function. And we're going to talk about functions of numbers that can often be described with symbols or words. So here's an arrow diagram for the squaring function, and I'll let you read over this text on your own. Squaring function just says take a number and square it. -3 squared is 9. +3 squared is 9. -2 squared is 4. 2 squared is 4, etc. At the bottom of page 1 here, we see that functions are represented by tables, formulas, and graphs. We're rarely going to use an arrow diagram like the example above to represent a function in this course. That's just to help us get the idea of what's going on at the very beginning. We're normally going to use either a formula, a graph, or a table of values. And you've probably seen the formula y equals x squared. That's the formula for the squaring function. You've probably seen the graph of the squaring function before. That's a very famous shaped curve called a parabola. And then here's a table of values written in a more traditional way for the squaring function. Often in a table we put the x coordinates, x values in order, right? And notice that we often use x to represent the input and y to represent the output. So a table of values lists some of the function's correspondences. If we have only a short table, it's nearly impossible to guess additional values not listed on the table. But sometimes there are enormous tables of values, such as those stored in a computer, which contain enormous amounts of information about a function. Let's go ahead and do exercise 2. Determine if y is a function of x in each of the tables below. Now, tables can be drawn vertically or horizontally. I drew these horizontally because the textbook has examples written in this way. But for example, example A, I could have written the table in this way, where x values 3, 4, 6, 3 correspond to 5, 1, 2, and 9. And now the question is this correspondence a function or not. If I were to draw an arrow diagram for this table, I could write 3, 4, 6. I'm only going to write the number 3 once. And then I have, I'm going to change the order of these numbers a little bit. 5, 9, 1, 2. I could draw the arrow diagram in this way, where 3 corresponds to 5. That's at 0.35. 3 also corresponds to 9. 4 corresponds to 1, and 6 corresponds to 2. So here's an arrow diagram representing the situation in Table A. Do you see how there are 2 arrows starting with the number 3? 3 corresponds to 2 different y values. So example A is not a function. Not a function because x equals 3 corresponds to more than 1 y value. That's an example A. Now example B, again, we could write as a table 1, 6, 5, 2, 7, 10, 10, 8, 8, 3. If it's easier to think of the table that way, you can write it vertically. Let's draw an arrow diagram here. I have 1, 6, 5, 2, 7. I only need to write each y value once. I'm going to write 10, 8, 3, because I can represent the arrows without writing the x and y values more than once here. 1 corresponds to 10, 6 corresponds to 10, 5 corresponds to 8, 2 to 8, 7 to 3. Now, when I look at these arrows, there's only one arrow starting at each input value, at each domain value, at each x value. Those all mean the same thing. So example B is a function. This is a function. So y is a function of x in that situation. So we're going to continue this handout in the next video.